So let's look at a system of linear equations in 3 variables that will give us infinite number of solutions. This will be a consistent dependent solution. So when I look at my equations, first let's stay organized and number them. 1, 2, 3. When I look at 1 and 2, my z's will automatically cancel out for me. I can eliminate 1 and 2. My z's are gone. Let's eliminate z from 1 and 2. Got equation 1 and equation 2. Let's just write them as they are. 4x minus 3y plus z equals negative 9. And then I have negative 3x plus 2y minus z equals 6. When I combine these two together now, my z's are going to cancel out. 4x minus 3x is x. Negative 3y and a positive 2y is negative y. My z's cancel out, and a negative 9 with a 6 is a negative 3. This will be my fourth equation. Now I need to get the third equation for my system into the mix somewhere. So since my z is already negative here and it's a positive here, let's use 2 and 3. So I'll go 2 and 3, and we'll eliminate the same variable. We'll eliminate z. Equation 2 is negative 3x plus 2y minus z equals 6. And equation 3 is negative x plus 3y plus 3y plus 2z equals 9. When I combine these two together, I can't quite do it yet. My z's won't cancel. I need to have the same coefficient with opposite signs. So I need to multiply my top equation by 2. Negative 6x plus 4y minus 2z equals 12. And on the bottom I can just rewrite the equation. Negative x plus 3y plus 2z equals 9. Now my z's are set to cancel out. I've got the same coefficient with opposite signs. So negative 6x, and negative x makes negative 7x. Plus 4y plus 3y makes plus 7y. My z's cancel, and 9 and 12 is 21. We'll call this one equation number 5. Now let's come over here and put our 4 and 5 together. Equation 4 is x minus y equals negative 3. Equation 5 is negative 7x plus 7y equals 21. Now we may be able to notice right off that equation 5 is just equation 4 times negative 7. If we see that, then we can stop and go ahead and say that there are infinite number of solutions. But if we don't see it right off, it's okay. Let's solve this by elimination and see what we get. So to make my y's cancel, I need to multiply the top equation by 7. When I do that, I get 7x minus 7y equals negative 21. I carry my bottom equation over. Negative 7x plus 7y equals 21. When I combine these two now, my 7x and negative 7x, they go to 0. My negative 7y and 7y goes to 0. My negative 21 and my 21 goes to 0. I have a true statement that's never false at this point. This statement is always true. 0 will always equal 0. And at this stage in my problem, I have involved all 3 of my initial equations. All 3 of the equations in my system are incorporated into this answer. Equation 1 and 2 led me to equation 4. Equation 2 and 3 led me to equation 5. So I've involved all 3 systems, or all 3 equations in this system rather. And when I tried to find a solution, I got a always true statement. This tells me, since I have all 3 equations in the system here, that I have a consistent dependent system with infinite solutions. There are an infinite number of solutions to this. Now you may be saying to yourself, well, Mr. Mahan, you like to do elimination, but I like to do substitution. What would it look like if I use substitution? So let's go back to this stage right here, where I've got my 4 and 5 written together. A good choice for substitution, let's solve for x. In that case, I get x equals y minus 3. Now let's plug that x value into 5. So I would get negative 7 times, instead of x,